Areas of composite figures. A composite figure is a figure that can be separated into regions that are basic figures. For example, maybe a triangle attached to a rectangle. So to find the area of a composite figure, first you want to separate them into those basic figures that we know, find the area of each basic figure, and then add those together. So let's take a look at these examples. The first one we see it looks like a rectangle here. I'll highlight it in blue. And then it appears to be half of a circle over here. So if I can do the rectangle plus the semicircle, that is going to give us the area of the entire shape. So to get the area of the rectangle, first I'm just going to do length times width. So that's going to be 15 times 34. So the area inside that rectangle is going to be 5/10. All right. We do notice that this is 15 over here, which means our diameter is 15. That means that our radius is half of that, so 7.5. So the area of the circle is going to be pi times 7.5 squared. But because it is half of a circle, we need half of that. So the area of the semicircle is going to be pi times 7.5 squared divided by 2. And when we do that in our calculator, we are going to get about 88.4. All right. Then to find the area of the entire shape, we will just add these together, and that's going to give us 598.4 feet squared. All right, let's take a look at part B. So in part B, I see two shapes here. It looks like two possibly parallelograms going on. We have one over here on the left in blue. We also see those tick marks. And we have one over here on the right. Let's make it green. All right. Now, in order to figure out these lengths, we're going to need a little bit more information than we actually have. So while this might be a good way to separate it, we don't necessarily have the full height. But what we do have is a little bit more. Now, we see that 40. If we just kind of draw this imaginary line and imagine that we have this triangle here, it's an isosceles triangle. Now, this isosceles triangle, if we were to draw an altitude, would give us two congruent portions, which really means that from here to here, instead of 40, is really a length of 20, and from here to here is also 20. Well, now if I try to take the area of the blue, that's going to be this parallelogram with a height of 20 and 24 as a base. So 24 times 20, that's going to give us 480 for the blue. Plus, let's find the green. So we have a base of 24 and 20 for the height. So again, 24 times 20, another 480, and that's going to give us 960 inches squared. All right, take a look at the next one. In part C, we see a bunch of things going on here. I do see some triangles. Let's see, I definitely have this one triangle here. There's a base, and we're given the height of it. So if I look at this one that I've highlighted in blue, and colors might be useful here, we would have the half. The area is half times the base times the height. All right. So that is going to give us an area of 266 in blue. That's this portion in here. To find the other triangle, which we can also do in green, let's see, that's got 1/2, the base is 40, and the height appears to be 10. So that's going to give us 200 for the green, and then we'll add them together to get the total, so 466 centimeters squared. All right, let's take a look at the next shape. It appears to me that we have two things going on here. One, we have on the left a triangle, and on the right we have, it looks like a square because I see the double tick mark on all sides. So to find the area of that square, we're just going to multiply the sides by themselves. So if that's 22, then they're all 22. All right, so the area of the square is going to be 22 times 22. and that's going to give us 484. All right, to that we need to add whatever the blue triangle is. Well, in order to get the blue triangle, we really need some information. We have a base. We just said that it's 22. So half times the base. But what's the height? What is this distance? Well, we see the measure of 42 is from here to here. We can chop off 22. That's going to leave 20 from here to here. So it looks like the height is going to be 20. So we're going to get 210 for the blue triangle. We'll add this all together. 210 plus 484 is going to give us 694 centimeters squared. All right, let's take a look at the next shape. So it looks like I have two trapezoids back to back. All right. So we have 20 and 40 there. We also have 20 and 40 here as our bases. So this is going to be, let's see, the formula for a trapezoid is 1/2 base plus base times height, so 20 plus 40 times. Now the height is not very obvious, but it does appear that these are equal. So if we just cut this in half, half of 64 is going to give us 32 on each side. All right, so that is going to give us, let's see, we're going to get 960 for the blue. And then let's take a look at the red. So we're going to have 1/2 40 times 20, or sorry, 40 plus 20 times the height, which is 32. And that also gives us 960. So when we add those together, we're going to get 1920, so 1,920 meters squared. All right. Again, we are going to have to take a look at these separate shapes. We have a triangle on top and a triangle on the bottom. The triangle on top has a base of 35. We also notice that we have these parallel lines here. We have that these angles are the same. We know that these are vertical angles, or sorry, those sides are the same, the top and the bottom, right? These sides are the same. We have vertical angles, and we also see that we have these angles are going to be the same, and that's because of these being parallel, they're alternate interior. Angle, angle, and then really we have enough information here. We also know that this angle would then be the same as this one using the same theory. So we have enough here to say these angles are, or these triangles are congruent because of ASA. So these are congruent by ASA. Okay. So the next thing that we want to do is to, or we could say AAS, that would work as well. We have enough information for either of these. So let's find the area. Well, if that's the case, if they are congruent, then this height and this height should be the same. So we'll just cut this in half and say that it is, there we go. We'll cut this in half and say that this is 7.5 here and 7.5 here. All right, so that top triangle up here is going to have an area of 1/2 times the base times the height, which is 7.5. So 35 times 7.5 times 0.5, that's going to give us 131.25. And then for the other triangle on the bottom, we also have 1/2 35 times 0.75. That's also going to give us 131.25. And when we add them together, we are going to get 262.5 yards squared. All right. In these next couple examples, what we're going to do is find the shaded region. So we're going to have to subtract out the white portion to get the shaded in part. And hopefully this copied okay. When we're talking about the shaded region, we're talking about in here, it's a little bit grayer than the rest of it. So in this space. So the first thing we're going to do is find the area of the rectangle, the entire thing. To get the area of that rectangle, it's going to be 50 times 30, length times width. So that's 1,500. Then we're going to subtract from that the area of the semicircle. And that should leave us with the portion that's left. So this is also 30, that's the diameter, which means the radius is 15. So that's going to give us pi, or really half of, right, because we want a semicircle, half of pi r squared, so 15 squared. So that's going to round to 353.4 for the semicircle. And when we subtract, we are going to get about 1146.6 feet squared. Okay. Same kind of concept here. We have this big rectangle, and we want to do the rectangle really minus 3 circles here. Rectangle, and then we're going to subtract off 3 circles. All right. Well, in order to figure out how long the rectangle is, we can actually use this radius of 5 to help us. If that's 5, that means from here to here is 5, and from here to here is 5. So that makes one of these dimensions 10. If this is 5, that means this is also going to be 5. And if that's 10, that means the radii here are also going to be 5, which are diameter of 10. So 5, 5. This is also 5, 5. 1, 2, 3, 4, 5, 6. 6 times 5 is 30. So our rectangle is 30 by 10. So that's going to give us 300 for the rectangle. And we're going to subtract off the 3 circles. So each circle, so we'll have 3 times each circle. Each circle is pi r squared, and r is 5. All right, so that's going to give us, for the circles, that's about 235.6. So when we do the subtraction, we're going to get 64.4 centimeters squared. And what that's finding is this area that's shaded. When we take away the circles, it's what's left behind. Think about cutting the circles out with a pair of scissors. This is that scrap paper that's left behind.